Hey, hello there, and welcome back to another video. So, Advent of Code, day not 10, it's still day 9 for me, although it's a bit late. I don't know if I'll be able to do this puzzle, or if I am awake enough. Maybe just part 1, we'll see. Let's see what day 9 is about. Day 9. Mirage maintenance. I'm never sure about the pronunciation of this. Okay, so you ride the camel through the sandstorms and stop where the ghost's map told you to stop. Where did they told me to stop? It's like the part 2 of the previous day was kind of messy. Like well, I guess you got some directions, but I doubt the camel walked all those like billions and billions of steps that we calculated on yesterday's puzzle. So the sandstorm subsequently subsides, somehow seeing you standing at an oasis. Okay, that's a long alliteration right there. The author of Advent of Code loves this kind of thing, and they are challenging to pronounce. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island, this one made of metal. Ooh. That must be where the parts to fix the sand machines come from. There's even a hang glider, partially buried in the sand here. What is a hang glider? Oh, these things. Okay, yeah, you hang in there. Makes sense. Cool. Hang glider, partially buried there. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. Wow, really cool. So we have been traveling through like airships, camels, hang gliders now. It's a really cool trip. While you wait for the sun to rise, you admire the oasis hidden here in the middle of desert island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone, so the oasis can be around for the next sandstorm-warm traveler. Okay. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis and sand stability sensor, cool, produces a report of many values and how they are changing over time, your puzzle input. Each line in the report contains the history of a single value. For example, okay, so we have different lines with different values, and they seem to have the same number of values each. Okay. To best protect the oasis, your environmental report should indicate a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input sequence. Okay, once all of the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. Okay, let's keep reading. In the above dataset, the first history is 0, 3, 6, 9. Okay, it's like it goes in increments of 3. Because the values increment by 3 each time, the first sequence of differences that you generate will be 3, 3, 3, 3, 3. Okay, it makes sense. So you calculate the differences between each digit. Note that this sequence has one fewer value than the input sequence because at each step it contains 2 numbers from the inputs. Okay, makes sense. And here we can see already that the differences between these 3 is going to be 2 zeros. Sorry. Okay, since these values aren't all 0, repeat the process. the values differ by 0 at each step, so the next sequence is 4 zeros. This means you have enough information to extrapolate the history. Visually, these sequences can be arranged like this. Okay, yeah, it makes sense. Also, this sort of looks like those Pascal triangles, although I think, the Pascal triangles go the other way around. They are like a pyramid, and you add up. Yeah, it's not exactly a Pascal triangle, but kind of like it. To extrapolate, start by adding a new 0 to the end of your list of zeros. Because the zeros represent differences between the two values above them, this also means there is now a placeholder in every sequence above it. Okay, and I guess you have to calculate A and B here. You can then start filling in placeholders from the bottom up. A needs to be the result of increasing 3, the value to its left, by 0, the value below it. It means A must be 3. Okay, A must be 3 because 0 is the result of, 3 minus 3, so this is equal to this minus this, so this would be this plus this. Okay, and then I guess B is going to be this plus this. Finally, you can fill B, which needs to be the result of increasing 15, the value to its left, by 3, the value below it. Okay, yeah. Okay, so it's not... I was worried for a bit here because of the A's and B's, like these placeholders that we had to like solve some sort of system of equations, but now it seems like you always have to do this plus this, and then this plus this, so it's easy. So the next value of the first history is 18. Finding all 0 differences for the second history requires an additional sequence. This goes... Okay, it's interesting. This one differs, like the difference between the two is incrementing by 1 here, and then it's all 1s, and then it's all 0s. So this is a very interesting way of extrapolation. Like then, when you do this, you're gonna get a 7 here, and it's like, this is really cool actually. I wonder if this method, I'm sure that this method is already like a known thing and I'm just discovering it now, but it looks like some sort of like differentiation, but these are not, these are derivatives, of course, they are derivatives. This is derivation. This thing is increasing. Well, like this is constant, the derivative of a constant is 0, and this is linearly increasing, and the derivative of this is 1, is like the slope of this, and this is well, is this quadratic? Kind of, but not quite, right? If this is not derivation, is something very, very close to that. But anyway, let's keep reading. So the next value of the second history is 28. The third history requires even more sequences, but its next value can be found the same way. Okay, so you do this kind of thing. I think I get the gist of this. So the next value of the third history is 68. If you find the next value of each history in this example and add them together, you get 114. Analyze your OASIS report and extrapolate the next value for each history. What is the sum of these extrapolated values? And the input is just many lists of numbers. And there are some negative values too here. And some things that alternate. Interesting. Some things that are all negative. Interesting. Okay. Okay, let's jump into the code. So jump into 2023, open the code editor, and let's start by closing everything, copying the templates, Encoding this thing, day 9, Mirage, maintenance, that's the pronunciation, yeah. And copy the template input folder, this would be day 9, and for the input we have all of this. Then for the sample output, it was 114, and the sample is these 3 sequences. Good. So let's think a little bit of how we are going to do this. This seems, at least for part 1, doesn't seem so complicated, I think. And it's kind of I'm thinking about this like in a recursive way, because it's like you have this sequence, and what you do is, okay, I'm trying to extrapolate the next value, and to do this you generate the sequence of differences and extrapolate the next value. So it's like you repeat the process again, which is kind of like a recursive call, until you get to the bottom case, which will be all of the values being zeros. So that's nice. Yeah, I think I'm going to try to solve it in a recursive way, because the other way probably of solving this would be to do it like in an imperative or iterative way. And you can imagine like having a loop. Well, you have the first collection of numbers, and while your current collection is like not all zeros, you keep generating the differences until you get one that is all zeros. You push those things into like a queue or something to process, and then you add a 0, and you start to do this process of like popping back and getting to the original, and then you get the final answer. Which is also like, I think, simple enough, but since, like, to my mind, the recursive version like came more clearly, let's try to go for that. So we have the input, we have to convert this into numbers, so this is simple enough. And by the way, this is like we have already done this like parsing number things for many puzzles already. I wonder if we should bite the bullet and like introduce a function that we can reuse to parse numbers. So I'm not going to do this now, just to not get sidetracked, but I'm going to take note of that in the README. Oh, I have also to write the notes for day 8. So let's try to do introduce common number parsing function, or something like that. Seems to be a party or something, and some neighbor apartments. So sorry for the noises. Also drinking some tea in the middle of the night. So how do we get the numbers? Let's say numbers is going to be a vector of, I don't know, 64 bits, not 74, 64 bit numbers. This is the input. Oh, it's not just the numbers, so we are going to iterate over each. Okay, let's do it top down. So the answer that we want is doing this extrapolation thingy for all of the sequences that we have in the input, and then adding those together, right? So well, let's maybe parse the sequences first. So let's call this thing let sequences a vector of vectors, I guess. So yeah, input lines. Is sequences the name that? Well, it's called history. Let's call it sequences. So it's the lines. We're going to do the parsing of each line. So for each line, we're gonna do line splits. We can just split by a space, right? And then each line could fail. So let's do, yeah, we need to parse this thing. So gonna parse and try collect, I guess. And then all of these we try collect. Is this okay? It seems to. And then we are going to, like the answer, let's call it just answer 1. It's gonna be a number, and just grab the sequences and iterate them, map them to, what are we going to have, like a function, let's say extrapolate history or sequence, sequence, and then sum out of this, like this function should return you the extrapolated value. So we're gonna have this, and we're gonna take a sequence here, which is well, no need to pass a vector. Yeah, we don't need to push things into the vector, I think. I'm not sure, but let's see. Let's pass a slice for now, and this should return a number. I don't know if this function will be will return a result or result type or not. So you don't like this because type mismatch. I think this is the kind of thing that will get fixed by simply doing this. Yeah, okay. And then we just print the answer. Okay. So how are we going to do this? I want to do it the recursive way. So let's start with how do you call it? Like the recursion stop condition or end condition or something. So if the sequence is consists of all zeros, so iterate if all of these numbers are, can we ask if it's 0? I just ask like this, then we're gonna, well, the extrapolated value is just gonna be 0, right? And then we're going to do something different here, some dereferencing, or maybe we can borrow here. Okay, so that's the bottom value. Good. In any other case, what we need to do is to generate the sequence of the differences, call this extrapolate sequence function recursively on that, right? So let's think about, okay, we have, let's see, I don't know, this example, we have thought about this case, the 0 case. Okay, like the extrapolation is 0. Now, if we were here one level above, how did we call this? Okay, we would do the differences of all of these. That would be, and call extrapolate value or extrapolate history in that. We'll return as 0, and we have to add this to the last of our values, and that will be our extrapolation value. And that's it. It sounds pretty easy. So how do we calculate the differences? Let's call it diffs. And this is going to be like, I think I could think about this in a very imperative way. Yeah. Yeah, let's do it in a very imperative way. I'm not entirely sure if there's probably a better way of doing this, but let's do it just pushing things to a vector. So in fact, we can know exactly the capacity needed for the vector is going to be sequence length -1. And if the length is 0, this is going to explode. So we probably want to check at some point if like it's 0. It's like, Well, let's think about the edge cases later. So how are we going to compute the differences? Well, let's say for we can use indices here, I guess. Oh, there is a function exactly for this kind of thing. We can say for A, B in sequence windows. Is windows what I want? Overall the contiguous length size. The windows overlap. If the slice is shorter than size, yes. Yes, it returns no values, if that makes sense. So if we have 2 values, we cannot make the differences. So we are going to see if the input has some of those conditions. So this iterator gives us slices. Isn't there like a... I would rather have like arrays or something, but I don't know if I can destructure these slices here, but we shall try. So diffs, we are just going to push A minus B, right? Oh, and by the way, this should not be unsigned, because we have already seen that there are signed numbers. So let's use signed numbers here. And okay, this is complaining, probably because it's the return value, and this is refutable match pattern. The match value is, yeah, okay. I'm sure I have already Googled this. So Rust array windows. Actually, is there an array windows? Oh, nightly only. I really want to use this. This is what I want. Okay. So yeah. Does iter tools give me this? Iter tools, array windows, chunks windows. Oh yes, we have already seen. No, wait, tuples is not what I want, because yeah, they are. I want these things to overlap. I want these things to overlap. Tuple windows. Okay, so sequence, iterate over this, and tuple. Oof, there are many tuple things. Circular tuple windows. Look at this. But tuple windows. Thanks so much, iter tools, for these kind of things. So we're gonna have these tuples. We can even dereference, borrow this. Why not? Oh, yeah, because you need to know the size of. Okay, this is fine still. The diffs is going to be, yeah, is of the correct type. So okay, we have now the differences, I think, and now what we do is call extrapolate sequence for the diffs. This is going to give me a number, and the number that I'm going to return is that extrapolated value plus the last value of my sequence. So this plus sequence last, and for now let's just say unwrap, because all of this may fail if the sequence is empty, right? Yeah, they shall be diffs. Okay, is this it? Does this work by any chance? So if we do cargo run, no need for release mode actually, and this is day 9, inputs day 9, and okay, I tried to do Control K there, but I think no, 62. This is wrong, but it did compute something. So let's do some printing. So got the sequences. We can probably print what the different extrapolated values are. So print line in debugger, print this thing. What do I want? Do I want to collect vec? Let's use this from iter tools also. Cool. Run this. 12, 17, 31. So I think we are falling short of what we want, but 12? Okay, it's not that far away, and 16 is okay. So let's do some more printing to see what the these recursive calls are doing. So let's put this into a variable. This is the result, and let's print here extrap result. Oh no, let's just simply first print the sequence that we are extrapolating, and then say, okay, this extrapolates to result. And I guess for 0, let's also print this. So extrapolates to 0. If we run this, oof, we get a bit more. Get 4 zeros, extrapolate to 0, that is okay. Then we should have, oh, all freeze. Oh, I was doing the differences the other way around, right? It should be, we have A and B, it should be B minus A. What a dumb mistake. So if we run this now, we get 114. And maybe let's run it with all these noisy things with the actual input. So yeah, let's go. And this is the answer. Let's see if this is the correct answer, and it is. Okay, good. So it was pretty simple. At least done in this recursive way, it was quite nice. I have to still clean up the printing, but let's see what part 2 is about, because part 2s lately have been very, very challenging compared to the part 1s. Need more tea. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding difference until the sequence differences is entirely 0. Then, rather than adding a 0 to the end and filling in the next values of each previous sequence, you should instead add a 0 to the beginning of each sequence of zeros. Then fill in the first values for each previous sequence. In particular, here's what the third example history looks like when extrapolated back in time. The third one, okay. So you continue until zeros, then these, if this is the difference between this and this, it means that this minus this equals this. So A minus B equals C, and A is then this minus this. Okay, so minus 2. Right, so, I mean, we did 0 minus 2. No, wait, how did we get this minus this? Adding the new values to the left side, I didn't understand how we should do this. The new values on the left side of each sequence from the bottom to the top eventually reveals the new leftmost history value 5. Doing this for the remaining example data above results in the previous values of -3 for the first history and 0 for the second history. Adding all these new values together produces 2. Analyze your OASIS report again, this time extrapolating the previous value for each history. What is the sum of these extrapolated values? Okay, so how do we do this? This is going to be, so, oh no, I was thinking I'm A minus B, but this is actually this minus this. So, okay, so this is this minus this. So B minus A is 0. So if we, how do you say, like when you do equations, you here x is, you know, 2 minus x is 0. So you can also say x is 2 minus 0, right? So this minus this is 2. This minus this is minus 2. This minus this is 5. Okay, so we do this minus this. The first value minus the extrapolated value. That's what we want to do to extrapolate back in time. So it seems like part 2 now is pretty simple compared to, unless I'm missing something, this is just the same function that we have, but let's call it extrapolate back. And you know what? I'm just going to call this thing extrapolate. And this extrapolate back. Okay, and part 2 is just going to be that. Answer 1, answer 2 is the same thing, but extrapolating back. Maybe for consistency I should call it extrapolate forth, but meh. Answer 1, answer 2. Okay, so in this we do exactly the same thing for the 0 case. We also compute the diffs the same way. But now, what were we doing? This minus this, and then this minus this. Okay, so the first minus the extrapolated one. So we're going to do sequence first minus the extrapolated value. Okay, and if we run with a sample, we get 2, which I think was what we expected. Cool, here we wanted 2. And for the input, input is this small number. I wonder if this is the correct answer. Yes. All right, this was the easiest part 2, I think, from this year, actually. It was just reversing what part 1 was doing. Awesome, I'm very glad that it was this simple. So we need to also save the answer. So let's search this command in the history. And then if we check everything, it should work. Awesome. And this was, yeah, surprisingly simple. So let's add all of this except the README. Well, add everything except the README because I don't want to commit that to do thing. Yeah, this seems nice. And what have we got? We're using this try collect here, which oh yeah, we were using this before. I was confusing with the try vec that we used before for printing. It's like I was having doubts about that, but this is pretty fine for the main code. And about this extrapolation code, there is of course some repetition, but I don't think it's worth like cleaning that up. I don't think. Maybe, well, maybe we could yeah, we could extract this how we do the differences, the sequence of differences. So yeah, and maybe thinking about what happens if you get to an empty sequence. Could that happen? Like if, I wonder, let's grab the sample and just put, I don't know, if you do 5 and 6, this will do 6 minus 5, it's 1, and then you have no differences to do and you never reach 0, so what's gonna happen there? The differences, I think, is going to be empty because you're not going to have any tuples. Then you're going to call this extrapolation on an empty sequence, and okay, that will match being all zeros because an empty sequence is all zeros too. The all predicate always passes for empty sequences, so it's gonna give you back a 0. Oh, I think this. Oh, but you won't be able to. Oh no, yes, you will be able to do this. So I think this doesn't explode. Let's actually run this with a sample, and it didn't explode. Awesome. So I was just thinking it would explode, but it doesn't. Maybe it would if we have. What happens if we have even one value? I think this shouldn't explode either. Yeah, and if we have like an empty sequence, yeah, okay. Parse int error. Interesting that we have well, no line number or anything. So Rust backtrace 1, I think is isn't there a way to print the backtraces? Rust result backtrace. I'm pretty sure that there is something. Yeah. Oh, if you use anyhow, but I'm not using anyhow. That's awful if the default, maybe I typed this wrong. Not nice. The samples having, so it's a parse int error. Where are we parsing that? It's, yeah, this is probably getting an empty string. Like, maybe yeah, this is something that I wasn't thinking about. But maybe I should. Actually, this is also related to what I mentioned in the beginning of maybe thinking about a function that parses numbers, because we are doing that in many other puzzles, and maybe make it like a robust function that doesn't fail in these silly ways. But it's kind of a letdown that by default Rust doesn't seem to like print. Yeah, to print backtraces for results. I was also running this in debug mode, right? Yeah. Okay. Meh. Not very cool, really. But anyway, let's extract this into a little function. So we are going to call diffs sequence. Or just differences. Okay, so we can do inlining of this. Maybe that's too much for the same expression there, but yeah, we have the differences, and we can have the same thing over here. And you know what? I'm pretty okay with this imperative code. I'm not sure if there is an obvious way of doing this. Oh yeah, actually this is just a map. What am I thinking? Of course this is a map. Man, I'm thinking too imperatively lately. So yeah, tuple windows, we're gonna map to just the tuples a, b. So same idea, but just map to b minus a. Come on, this was easy. And collect. No need to say collect vect, it's already on the return type, so we don't need to do any of that. Yeah, that should do it. We run check all, and everything is passing. So look at this. This is quite pretty. I like it. And I mean, if I were being like super pedantic about memory usage and things like that, I think that these differences is not even necessary to compute, because you compute all the differences. Oh no, I think it is necessary, yeah. Because then it's going to be read, like you're passing all the differences to the extrapolate function, and it needs to read them all to, well, make the differences again. Okay, I think it is needed, yeah. But okay, this was a pretty simple puzzle overall, I think, or at least a pretty simple solution. Yeah, I'm super fine with this code. I think this is maybe the shortest solution of this year, or one of the shortest for sure. So let's commit this and say add day 9 solution. And before I forget, let's also make a little thumbnail. So toilets and blah blah blah. This is day 9. Don't forget to update the day, and let's say recursion is nice. Yes, and a smiley face, why not? Even maybe like and I want a heart emoji. Do I have like I think I have a stupid application for that, because of course in Linux having a emoji picker is still considered like you know, I don't know, something that doesn't come by default. No, of course this won't work. But you know what could work? Editing this afterwards. So let's clear the screen and just print recursion with some spaces. Yeah, and I'm just going to put a smiley face somewhere in there. Not a smiley face, sorry, a heart there. So maybe we can even show the recursive functions. Look at this. This is all basically the meat and potatoes of what we did. So that's really nice. I really like this this kind of recursive expressions. I always feel nice about like thinking about something abstractly and like getting it right. Like a sort of like thinking about very purely about the data, and not so much about like sequences of steps or something like that. Although I have to admit, I was really dumb of expressing the differences, like, okay, I'm going to make a vector and push into it, but I don't know, that was just a derp of my brain. But that is it for today, I think. If you've followed along and are still watching the video, thanks for doing so, and see you later, I guess. Bye bye.